The Alamo asteroid or comet hit north of what is now Las Vegas about 377 million years ago. So here's Las Vegas, and this represents the approximate size of the crater, 60 miles. Of course, it's all eroded and broken apart because of extinction and all that. But this gives a rough idea how close it is to Las Vegas. And so the area that I hiked up to search out and take pictures and videos of the breccia from the impact and the tidal waves and the huge shock waves that broke up the area are out here. This would be the crater. And so I'll pause this and then I'll show you the other diagram. But I wanted to give context of how really close it is to Las Vegas. That's the crater itself. And so I think I'll click on these individually. But here's what it looked like at the time. Of course, the dot, that's the area at the time. That's what it would look like. And this shows the effect of the impact, and then the tsunami washed up and did this. So all this area here that shows the wash up off on the right, just picture that's, as far away as like Las Vegas and, well beyond Las Vegas. This is another picture from the research paper that shows the impact. In other words, that circle that I showed on Google Earth. And then, like, here's the rim area and huge breccia out in here. And here's Las Vegas. And so it shows the effect of like the tidal wave well past, Las Vegas. Of course, out here would have been the open ocean at the time. This picture of Nevada, be aware that the left side is chopped off. It's missing, so it makes the state of Nevada look weird. Let me pause this. This is just a quick read of Wikipedia, a screen capture. Of course, you can go to Wikipedia, type in the Alamo bolide impact. All this will come up. This, what you're looking at, is a screen grab. It's a picture. Also, of course, on YouTube, if you type it in, this is the best video on it, is this one.
Rocks and dust. The speed at which these hit the Earth exceeds 45,000 miles per hour.
So this is by Kimberto. And
here's
so
a list of possible evidence indicating
I'll put the link.
Occurred. This map shows Nevada in the late Devonian when it was almost entirely underwater.
I'll put the link. Part of this is free use for scholarly purposes, for educational purposes, not for profit, of intellectual geological information to share with others non-professionally, and like I say, not for profit. Okay, that being said, now I'm going to paste this onto my video that I'm doing. So you're seeing it real time here. So I'm going to put this at the front. And this shows all the other stuff, and I'll do a voiceover telling what pictures are. So that ends this recording. Now, kind of narrate. I had just arrived at the site, and so I'm showing some of the... See, there's the interface right there. Right there. Some more material. This breccia did not come from the impact. It didn't travel from the crater. This is from huge tsunamis and upwash and backwash, and also unbelievable seismic shock waves, far beyond what you could picture for an earthquake, like Richter 13. you know, there's the interface. Notice those kind of normal layers there. See the normal layers. Here's the interface. There, you see that reddish material? There. See, it's churned up, and then everything above it is shattered breccia. This was my first video I did when I arrived at the site and realized I had found it. Of course, the breccia is limestone breccia because the asteroid hit a calcium carbonate limestone continental shelf, shallow sea. Is just a picture. In this area, we don't have the huge breccia that are like as big as houses like they have over at the impact. This is a much studied area, and so they've taken core samples for magnetic dating, stuff like that. But that's exactly right above the interface right there. The lower left of that video is not breccia. That's normal layers. And there's the interface from a distance. The holes, those core sample holes are there, but right in the center, that's the interface. There it is again. And like I say, the lower left, that's not shattered breccia. That's why they took those samples right there, and also why I took pictures. My pictures are heavily on the exact interface. Just to be able to look. So in case somebody sees something or wants to stare at the breccia. So this material could have washed way up and way back, thousands of feet. Remember that there's the interface, another picture of the interface. It's about 60% of the way up, just below it. See that white layer? That white layer with those streaks? That's the last thing that was going on when the asteroid hit. And at 60% on up, that's all shattered. Another picture of the interface from a distance instead of just close-ups. Everything above that brownish line of the displaced chert is shattered breccia. And even the material below, by the way, is shattered because of the huge, what's called seismites. All of the stuff you're looking at is also seismites from the huge shock waves that hit. Just a view of the city from where I was at. Another view that I took from where I was at. That ends this one. Okay, now these long pictures, I want to explain something. Right there is the interface, like my thumb. That is kind of sandy, mixed up sandstone. And then the impact occurred. But you see the brecciated material above, like where my fingers are? That brecciated material was from a huge wave that could have washed up 20 miles and then washed back and forth over a distance of 10 to 20 miles. You see what I'm saying? Okay, now see those layers there? See how nice they are? That's the last thing that was going on when the asteroid hit. And then above it is the interface. And then just the stuff you see, and then out of screen up on top, that's crushed up brecciated material that washed and sloshed back and forth, possibly over several times over a distance of miles. This is a close-up of the exact interface, that dark line down there, the dark part, and then up above is the perturbed material, just a picture I took because it interested me. Don't picture that thing there like it just came from a few inches away. It could be from 10 miles away. Okay, that concludes this video. One more quick recording to end the video. Anybody that wants more information to discuss geology, maybe you're in the area, whatever, don't hesitate to email me. I'm not a mysterious person. Jay Silverheels is Tonto on the Lone Ranger. That's not my real name. My real name is Jeff. You can email me at jeffhome10@me.com, just like it sounds. jeffhome10@me.com. Thank you.